There's something buzzing around. There's something buzzing around. Good to see you all back. Ladies and gentlemen, Google for any random top 3 new protein sources, and what do you get? Plant protein, cultured protein, cultured cells, and insects. So I think it's a very wise decision for ProVeg to also include a presentation on insects, insect proteins. And we're going to invite to the stage a woman all the way from the United States who's going to tell us all about the recent insects. And her title is, Should We Eat More Insects? More insects? Yes, more insects, because I found that every year, every one of us is eating at least 500 grams of insects. All kinds of cell residues remaining in our food. So I'm very curious about this title, Should We Eat More Insects? And if yes, how? I would like to invite to the stage the International Engagement Project Coordinator of the Good Food Institute. Please give a warm welcome to Anni Osborn from the Good Food Institute in the United States.
Hi, everyone. So I'm Anni Osborn, and I am the International Project Coordinator for the Good Food Institute. I do a number of things at GFI, but one of the things that I try to do is keep in touch with international stakeholders. So if you have questions about our general work at GFI, or this presentation in particular, you're welcome to get in touch with me during the rest of the day or afterwards via email. So today I want to spend 25 minutes or so talking about some of the general trends that we see in insect farming, as well as the advantages and the disadvantages that we see in pursuing insects as an alternative protein to replace conventional meat products. This is the first time that we as an organization are speaking about insects. I'm very curious to hear what other stakeholders think about this topic. So definitely welcome questions after this presentation and later today. I was asked to give sort of a pro and con for insects. I will say that at GFI, we generally see more value in plant-based protein and cell-based protein alternative spaces than we do in insects as protein alternatives. But we are excited about the potential applications that insect cells might have in cell-based meat production. And so I'll wrap up this presentation with just a couple minutes of discussion about the role that insects might play in clean meat. And I'm going to use cell-based meat. That's what we're starting to say in the US, but it's clean meat, cultured meat, all these words. So I'm just going to start with a quick summary of what insect farming might look like as part of our future food system. And to start that, I'm going to talk about what modern-day insect farming looks like now. So people in many parts of the world eat insects already. That's why the title of this talk is Should We Eat More of Them? Eating insects is prevalent in tropical areas in particular, in places like Southeast Asia, southern China, and sub-Saharan Africa. Historically, people have typically eaten insects that have been gathered in the wild or farmed at a small village or neighborhood scale. But today, what I want to focus on is a different scale of insect protein production, a much larger scale of production and consumption. Because when people talk about insects as an alternative protein to feeding the world, they generally aren't talking about wild harvest insects or insects grown in a small neighborhood farm. They're talking about insect protein at a large industrial scale. And typically, when we talk about insect protein at scale, we're talking about two different use cases. The first is insects being used as a protein-rich feed intended for farmed animals. And the second is insects being raised specifically for human consumption. So we're talking about insects as feed and insects as food. And I'll talk about this a little bit more, but in terms of feed, we typically see insects intended to be used as an alternative to fish meal in the aquaculture industry. And in terms of food, we often see them as powders or protein fortifications in foods like pasta or in meat blends or in protein bars. Although there are some more like meat-like options that are available. So let's talk about insects as feed first. Insects are often presented as a more sustainable form of feed for farmed animals than commodity crops like soy or corn or wheat. And one of the strongest arguments that's used by proponents of insects as feed is that insects can convert otherwise unusable crop waste, think like the stems and the stalks of a corn plant, into high-quality food for farmed animals, specifically high-quality protein. So farmed animals that eat insect-based food, they have similar outcomes to farmed animals that eat conventional food. Those are similar outcomes when they're alive, similar health outcomes, and also similar outcomes when they're slaughtered and become meat. They make a similar product. Generally, the companies that are producing insect feed for animals, they raise the larvae of black soldier flies or of mealworms. So for insects as food, insects are also often presented as a more sustainable protein option. And in particular, they're presented as more sustainable than conventional animal agriculture. And it's certainly true that insects do compare favorably, especially along environmental metrics, when the baseline is conventional animal products. Insects convert food to, they convert their feed into food for humans more efficiently than many livestock animals. And that means that less food has to be fed to insects in order to raise those insects to feed humans. And to the best of our knowledge, most of the major companies that are planning to market insects as food for human consumption, they're making products that are intended to fortify other foods. So the retail products that we tend to see are things like fortified pasta or cricket flour, like ground up crickets that are mixed into other grain flours, and then also things that are put into snacks like protein bars or chips. There are also companies that want to sell whole dried insects that are intended for frying or for other home cooking purposes. And then, of course, there are meat analogs like an insect burger. Generally, the insect species that you tend to see for these use cases are mealworm larvae and crickets, although as we see more companies being founded, you also see more species being used. So one of the things that we really want to do, or that I really want to do in this talk today, is evaluate farmed insect protein. Why do we think that it might be good or bad? And when we talk about insect farming in comparison to other forms of food production, we really want to look at its effect on problems that are associated with our food system. And we want to talk about its effect relative to the effect of conventional and other alternative options. So how is insect farming better or worse than our other options? So to answer that question, we first have to identify what we want to see in a transformed food system. So I'm going to simplify for the purposes of this discussion. I'm going to talk about 3 goals that are really inextricably linked. The first thing that we want to see is a food system with less meat consumption. Pretty sure everyone in this room is on board with that. We've been talking about it yesterday and this morning, so I'm not going to go into detail. Similarly, we want to see a food system that doesn't cause environmental degradation. And finally, we want to see a food system that will reliably feed 9 to 10 billion people in a few decades, one that is resilient to environmental shocks and to other threats, one that will get calories to people when they need them. So how might insect protein, compared to our other options, help contribute to the changes that we want to see in our food system? How could it contribute to reduced meat consumption, reduced environmental degradation, and a more robust food system? We're not really going to talk about conventional animal agriculture as another option, even though that's what insect protein is usually compared to, and that's because we know that conventional animal agriculture does not work. That's the system under which people eat too much meat, under which we harm our environment, under which we're concerned that we won't be able to feed our population. We already know this doesn't work. So for the purposes of this presentation, I'm going to be talking about insect protein, specifically farmed insect protein from live insects, assuming that the other options are plant-based meat and cell-based or clean meat. These are the products that we've been discussing yesterday and this morning, and they're the products that we at the Good Food Institute are the most familiar with and that we see as the best bet for transforming our food system. So, let's get started by just discussing the pros and cons of insect protein by asking how each kind of food contributes to our first goal: how do we effectively reduce meat consumption? And as we've heard yesterday and this morning, there are a number of trends that indicate that consumers are interested in switching away from meat. But at the same time, we do still see that consumers are eating very high levels of meat. Per capita consumption of meat is on the rise in certain places, especially where meat is abundant, and there's increasing meat consumption in developing countries where disposable incomes are rising as well. So our thesis at the Good Food Institute, and this is something that's been mentioned before, is that in order for a typical omnivorous consumer to choose a meat alternative product over a conventional meat product, the alternative product has to be on par or even better than the conventional product in terms of three criteria. And those criteria are taste, price, and convenience. Taste, price, convenience. Everyone, even people who are trying to make decisions that are ethical or health-based about the food that they purchase and eat, everyone is influenced by what food tastes like, how much it costs, and whether or not it's convenient to eat. Convenient here, it means both that it's available where I buy food, and I know how to prepare and eat this food. I don't have to change my behavior around food when I have to consume this. So, this idea has come up in a number of presentations so far, the idea that things need to be cheap, tasty, and easy to make. People also talk about health. I just want to drive it home here. These are the three things that nearly everyone bases their buying decisions upon. So, plant-based meat is already well on its way towards being competitive in terms of these three criteria. In restaurants and grocery stores where plant-based meat products are already available, we've observed that flexitarians and other meat eaters will choose the plant-based foods on menus that also have meat, and in grocery stores that also serve meat. The success of brands like the Impossible Burger and Beyond Meat, these are not just due to vegans and vegetarians, but also to flexitarians. The plant-based products that we have are tasty, they're fairly cost competitive and getting cheaper, and they're convenient, and they keep getting tastier and closer to meat. Importantly, flexitarians are also choosing these options instead of, and not in addition to, conventional products. So if somebody orders a veggie burger, they're not going to then order like a regular hamburger the same day. They will feel like that need has already been met. So that means that these plant-based meats are directly replacing meat meals and causing meat consumption for these particular consumers to go down. For cell-based meat, we obviously don't have empirical consumer data because it just, consumers aren't eating it yet. But we can think of it as an even more direct substitute for conventional animal products because it's meat. It just is meat. And for any consumers that might have a deep cultural attachment or emotional attachment to eating meat, cell-based meat might be even a more attractive option than plant-based meat. There are a number of potential consumers for cell-based meat, but maybe you guys can imagine friends or family members who would just never in a million years consider eating a veggie burger or veggie meat, even if it was plant-based meat that really mimicked the experience of eating meat. Cell-based meat is, at the very least, for this kind of consumer. So think for a minute about that potential consumer, the person in maybe your family or your office who is just totally not on board with any of this stuff. Think about what it's like to try to convince them to eat plant-based meat. And then think for a moment that instead of offering this person plant-based meat, you're offering them a meatball made out of worms or just caterpillars and fried crickets. Is their reaction going to be better, or is it going to be worse? So the reaction that some of you are imagining is commonly referred to as the ick factor. And we all know that there's an ick factor associated with insects, especially in the West, but all over the world. But there are actually other reasons to think that insect protein might be less effective at reducing meat consumption than plant-based and cell-based meat could be. So one of the things that a substitute really needs to be is convenient. So substituting alternative products for conventional meat, that only works if we don't require people to fundamentally change their behavior around food. Insects cook really differently from meat. You can't necessarily just swap them in and out of a regular diet or cuisine. And we think that this means that there's going to be a lot of different recipes required if people start to adopt insects. And that just means that there's going to be a longer adoption period required if we start to make this switch from meat to insects, then from meat to plant-based meat, and eventually cell-based meat, because, again, that just slots right into the diet. Another important thing to recognize is that in cultures where people already eat insects, these are places where we might think that there's less of an ick factor, someplace like Thailand, where entomophagy, or eating insects, is very common. Insect consumption actually tends to be associated with lower income cuisines. And so there are insects that can be considered delicacies there, but mostly insects are consumed by the poor and not by the wealthy. And what this means is that empirically, we actually see people paying a premium to not reduce their meat consumption, even when insects are frequently available and frequently consumed. As soon as you can afford not to eat insects, you stop doing it. So there's one other theoretical mechanism by which insects might reduce meat consumption in addition to just directly substituting in. As I've mentioned, to our knowledge, most major insect companies are trying to produce food for humans by grinding insects into powders, using these powders to fortify products. We think that this is not a particularly efficient way to reduce meat consumption. We think that there's generally a misconception that supplementing protein in one part of the diet will cause people to eat less meat and meat-derived protein in another part of their diet. And the reason that we think that this is a misconception is that in many parts of the world, most parts of the world, people eat more protein than is recommended. Some of you may have seen this graph. It's from the World Resources Institute, published in 2016. The reason that we see everybody above the recommended value is that it's not split by income, it's split by region. Obviously, there are people who do not eat enough protein in the world. But what this shows is that anybody who can afford to, typically, vegans and vegetarians accepted, typically people are eating much more protein than is recommended every single day. So in the US and Canada, which is where daily per capita average protein consumption is at the highest in the world, in the EU, where it's the second highest, people are eating well more than 50% more protein than is recommended every day. So given that these consumers, these average consumers, are way over consuming protein, there's no particularly compelling reason to think that if we supplement more protein in one part of their diet, they'll eat less protein in the form of meat in another. So the general takeaway from this is that a fortified pasta meal, like a pasta that's been fortified with cricket flour, that's going to replace an unfortified pasta meal. It's not going to replace a meat meal later in the day. So that's the general sense that we have about how to reduce meat consumption. I want to ask our second question now, which is, how does an alternative protein contribute to reducing the environmental impact of the global agriculture system? I know that today is the Clean Meat Day, so apologies, but I'm not going to compare insects to clean meat here. There's just a lot of debate about the environmental impact of clean meat, and there will be a full discussion of that this afternoon. I'm not an expert here. Dr. Tuomisto is going to do a much better job discussing this than I could. So I'm just going to talk about plant-based meat and insects in answering this particular question. So one of the things that really contributes to the environmental impact of a given food is how much land you have to use to produce it. So in a conventional animal agriculture system, you have to use a ton of land growing crops to feed to animals, and then you feed the animals to people. The approximate ratio is that you need 9 calories of food that you give to a chicken, which is the most efficient, typical form of animal protein, to get 1 edible protein for humans back out. This makes sense if you think about it. If we, as humans, just spend the day lying in bed, we still need to eat something. The same thing happens with animals. And the same thing is true of insects. insects are a little bit better at converting energy into food for the people who eat it or the animals that eat it than traditional livestock animals are. And I do want to say that we don't have the exact same statistics for comparing insects to poultry. So we can't say like how many energy calories will go into an insect and how many energy calories will come out. But what we do have is the feed conversion ratio, and that is the weight of feed that you need to get a certain weight of insect out. So I've just written varied here. So the weight of feed that you need to give insects to get a certain weight of insects back out, that varies a lot depending on species. It is typically lower for feed species, so insects that are intended to be fed to aquaculture fish will typically have much lower food conversion ratios. You need 4 or 5 kilograms of feed to get 1 kilogram of insects back out. In the absolute best case scenario, it's about 2 kilograms feed to 1 kilogram insect out, but this is very hard to replicate. Food insects that are intended to be directly consumed by humans, they tend to have higher food conversion ratios that are more comparable to poultry, edging up towards 9 or 10 kilograms of feed to 1 kilogram of insect. So this is not as technical a presentation as the first two of the day. My science has stick figures, which makes it very accessible. So we have different units, but I'm comparing them anyway, just to get the point across. The takeaway is that feeding food to insects means that you're adding an intermediate step between plants and humans. That intermediate step is called a trophic level. So it's true that insects convert food much more efficiently, or as efficiently, depending on the species, as poultry, which is the most efficient traditional livestock species, or chickens are the most efficient traditional livestock species, and the comparison is more favorable when you look at larger animals like cows. That said, feeding plants to insects still means that you have to grow more plants than if you were just to feed those plants directly to humans. In the absolute best case scenario, the feed conversion ratio is 2 kilograms of feed to 1 kilogram of insect, and that's really for feed insects anyway, so you wouldn't be feeding them to people. Some of you might be saying, wait, I heard that insects eat waste. So in fact, you shouldn't be growing any more crops at all. You should just be taking waste streams and feeding them to the insects. And that means that this whole incredibly scientific, detailed, and research diagram is incorrect. How could you? So in fact, it seems that feeding insects with food waste is only scalable if the insects are intended to be fed to livestock. So it's only scalable if the insects are going to be feed. Food waste streams actually vary a lot, especially if you're talking about like municipal waste streams, which is where a lot of food waste comes from. Different food waste streams can change the nutritional profile of the insects that they're fed to. They can change the amount of feed that the insects need, and they generally create too much variation to be very profitable. That means that at an industrial scale, and often even at smaller scales, food will still have to be grown specifically for insects that are intended for human consumption. And that just brings us back to the same problems with inefficiencies that we see in conventional animal agriculture. So we can talk about insects as feed who can convert these waste streams into edible protein. But the problem there is that they're still contributing to the system of animal agriculture that we're trying to transform away from. We really don't want to compare insects to our current broken food system. We don't want to see how we can make incremental steps to feed animals more or less crops. We want to reduce the number of animals that we're feeding in general as we reduce meat consumption. So it is true that insects provide a more environmentally, or a lower environmental impact way of feeding animals that are intended for food, but we want to reduce the amount of animals in this system, period. So in this case, we really don't want to put insects into the context of the broken animal agriculture system. We want to put them into the context of this better system that we're building. So to sum up this, insects are associated with the same problems of food waste and inefficiency that we see in conventional livestock, even if it's at a smaller scale. So when we eat plants, we directly eat the plant. It's true that we do dispose of some edible portions if we process the plant, and Dr. Van der Goep talked about this yesterday, that there is some waste as you process plants more, but you still virtually never end up with the same amount of waste that you see if you're feeding plants to another trophic level before you feed them to people. And it's also easier to repurpose some of that plant waste than if you're dealing with insect excretion. So we feel that here, as well as with reducing meat consumption in general, insect protein is not particularly competitive when compared to plant-based meat. And again, cell-based meat, the environmental impacts will be discussed later. Please don't ask questions about that. Oh, sorry. We have one more question. So the third question is how we minimize risks to our food system while we feed 9 to 10 billion people. How do we create a robust food system? How do we create a food system in particular that is resilient to disaster? And I'm going to talk here about a tail risk, something that's very unlikely to happen, but something that if it were to happen would be very, very bad. So last year, there were several hurricanes that hit the United States. Some of you may remember seeing that in the news. Some of you might be from the region. But the eastern seaboard of the United States experienced breaches in several concentrated animal feeding operations, and that included escaped livestock. This happens pretty infrequently, but the reason that I bring this up is to point out that it's really hard to separate farming and our food system from the rest of the environment. Even if you try really hard, accidents happen, disasters happen. Livestock operations just can't be kept separate. So even though insects could be a lot more isolated than traditional livestock, and the risk might be a lot smaller, the risk of release of farmed insects would have a much more devastating effect on local agriculture, and it could negatively impact an entire region's food security. There's one aspect to the risk of escape for farmed insects in particular, and that comes back to the way that we breed animals and potentially insects for consumption. So poultry, over about 50 years, has changed significantly, mostly through selective breeding. Insect generations are much, much shorter, which means that changes happen a lot more quickly. So enormous insects can be bred in very short amounts of time. And they would be bred to just eat a lot and breed a lot, so that they would have even faster generations and we could harvest them more. So insects that have been bred specifically for human consumption could cause even more devastation than standard insects if they manage to escape. And a big factor in insect escape is that there's literally no way to corral them. You can't go out and catch like a bunch of crickets the way that you could maybe get pigs or chickens back into your feeding operation. So again, this is it's a low probability of risk, but it's a very high impact situation if that were to happen. We think that generally just doesn't contribute to the robustness of a food system. Plant-based meat avoids this issue because we already understand how to grow plants. Plants do spread, but if we had a plant-based meat system that required a lot more different plants to contribute, if we had a variety of plant-based ingredients, they could contribute to biodiversity within farming ecosystems, and that generally contributes to the robustness of a food system. And clean meat, of course, is not mobile. It doesn't move. Can't escape. I do want to note also that there are insect breeds that are less likely to move, so any insects that are in larval form are not going to get very far should there be a breach, but larvae also grow up very quickly and as soon as they get wings, it's a problem. So I've discussed a couple of the reasons that we think that insects are not an ideal solution to the problem of meat. I know that we're a little pressed for time. I just want to bring this up very quickly because it is Clean Meat Day. But we do think that insects could fit into our future food system as a potential applied, starting that sentence over. We do think that there is potential for insect cells to be applied in cell-based research. So this slide comes from David Kaplan's research group at Tufts University. It's from Natalie Rubio, and it just details some of the reasons that we think that insect cells could really contribute to do I have time to read this? I'm just going to go through this slide real quick. So insect cells are very durable. They can survive in a wider temperature range. They have fewer pH and osmolarity requirements. They scale up pretty well because many insect cell lines are already available for protein recombination, and they're easier to grow in a serum-free media. So it is possible to mix insect cells in with a number of different cell-based meat applications, but they're also just really useful for research. All right, that was very fast on that slide. You're welcome to ask me more questions about that later. Thank you so much for listening. I'm happy to take any questions you have now or later.
Sorry for rushing you up. I really liked also your final slides, bridging between insects and cultured meat. Really liked it. Thank you so much for your impartial view on insects. A question from the audience. Anybody? There is one. Yeah, you take that. Sorry, where? Let me hold the mic, please.
Okay, thank you for a very nice and interesting talk. My name is Hilde Andenes. I'm from Norway. My question regards sentience, because one of the motivations of moving away from conventional systems is, of course, suffering. And the more we learn about animals and their physiology, their behavior, and their cognition, the more animals tend to be considered conscious and to be sentient. Do you have a comment to that?
Yeah, for sure. So it is, I think this is a room where people are a lot more receptive to the idea that insects might be sentient. It's not necessarily the best way to get into this discussion with a general audience. It tends to induce some existential dread to think about trillions of insects having meaningful lives. But I think that, basically if you assign any probability above something insanely small to the idea of insects being sentient, the sheer number of insects that would be affected by insect farming makes it something that's worth considering. But again, I don't want to say that it doesn't matter, but it's just an odd idea if you're talking to a general audience. But it certainly is a risk that we should consider, and it is another reason that we might reconsider live insect farming.
Okay, ladies and gentlemen, we're buzzing on now. A big final hand for Anni Osborn, the Good Food Institute.